really clear whether or not you're doing a science fair project and entering it into the science fair, you still have to do the project itself. You still have to do an individual science fair type project, but there's lots of different options you have. If you're entering it into the science fair, the only difference is January 15th, you have to be basically done, because that's when our school science fair is, and that's when we're going to judge you. You will have opportunities to refine it, and then I think March 15th is where the international fair is. But if it's not good enough by January 15th, you're not going to be, entering it and refining it. So everyone's final project is going to be due March 20th. Whether you do the science fair or not, you still have to do the science fair project. So where you want to start is, what do you care about? What's some background information? And from there you can really deduce some things. So if you haven't entered your Google form yet, you need to pick 3 things you care about and find 5 background topic or 5 facts about it, and write it down and get it to me, and we'll sit down and talk about it. But so from there, you're going to look at it and go, okay, what do I really care about, and how do I want to go into this? Do I want to ask a question? If you want to answer a question, ask a question, then you can pick. Do you want to do an actual science fair project, a typical lab investigation and get some data, or do you want to do a field investigation and get data? For example, do you want to see how different sunscreens actually affect coral by testing different effects of sunscreen on coral in the lab? Or do you want to go out and actually take a 3D camera and be measuring coral in different areas and do some sort of longitudinal data here? Now, or you might decide that you actually want to propose a solution. And so in order to propose a solution, you need to know what the problem is. To know what the problem is, you have to do some sort of audit and get some pre-data saying, here's the problem. And then from there, you can say, how do I actually want to do this? Do you want to do it, in which case you propose it, you go through, you get post data, and you analyze your data. Now, it's possible that you can't get it done in time, so you might have to just propose the project and make a model and get data off of the model, whether that be a computational model or whether it be a physical model. Like we discussed, for example, maybe there's a ditch that fills with stagnant water and there's always mosquito in it, so you do some sort of audit saying there's this much water that's always standing, there's this much mosquito larvae, etc. This is why it's an issue. You propose it. Maybe it doesn't get done in time, so you make a model of the ditch and you say, here's where my solution would have been, and you show how it would have drained, etc. But you need to get data. Now, it's important to run 5 trials and pick your best 3. Now, from there, for your science fair project, you want to really look at it and go, okay, here's where you're getting your grades from. Quarter 2, you're going to get your grades from a lot of check-ins of what do you care about, what's your background information, all the data, the Google Forms that we're doing. You're also getting a major grade off of your log. You need to meet with me 8 times. You have a green rubric in class, and you have a log with 8 times to meet with me. Quarter 3, you're going to get a grade on your rough draft and peer reviews, and quarter 4, you're going to get a grade on your final project itself and the whole scientific investigation rubric going straight down. For quarter 2, you're going to do pairs. You're going to be making models where you're going to teach, show, answer questions, and they're going to be engineering. You're going to have some different things that you can pick from, but you are going to work together on this. They do need to be heavily into the whole engineering and being able to express some sort of concept. If you're in environmental science, you're doing a lasting change, and that's a group project. You already started it in quarter 1. Quarter 2, you're going to get a grade on the log. Quarter 3, you'll get a grade on your log and your sharing. Quarter 4, you're going to get a grade on your log and your pre and your post data. Whether or not you complete the project, you still have to have some sort of model, some sort of data by the end of it, showing computational data, etc., showing here's our audit, here's what we proposed, whether you actually get it done or not. Now, quarter 3, you're going to have an individual project. I don't know if we're going to do a model or a puzzle this year. We're going to vote on it. I was thinking maybe we could do a fun middle school activity, maybe do something like that and put it in our open house. Quarter 4, we will have our class fair during final week. And this is where you're going to show off your science fair project, your models, your puzzle, etc., and your poster or your painting that you made, and you're going to go back and kind of redo it. Bio, you're going to have to do it before finals because your final is the EOC. But everybody else, we're going to do this fun share fair during finals. Hope that clarifies everything and gets you a little bit more excitement. We may or may not have something going on Q4 project-wise. I'm still deciding what that'll be, but this is what I have laid out for you so far. Very different projects, okay?